Today we're starting a new unit on sequences, and today we're going to talk about finding the next terms. To start off, we need to know what a sequence is. A sequence is any list of numbers or other objects that changes according to some pattern. For example, we can have number sequences, picture sequences, or letter sequences. For today, we're going to write what is called a recursive rule. A recursive rule is a rule that tells how to find a term from the ones before it. When we talk about terms, those are the individual numbers or letters or pictures in the pattern. So we're going to write a rule that says how to get from one of these terms to the next one. When we do this, we will write them in words. For example, if we look at this sequence, 3, 5, 7, 9, 11, I need to write a recursive rule that says, what do I do to the 3 to get 5, to the 5 to get 7, to the 7 to get 9? And it needs to be something that is the same each time. So here, when I look at this, it's going up by 2 each time. So mathematically, I would say my rule is add 2 to the previous term. For the next example, 5, 10, 20, 40, 80, it's not going up by the same amount each time, but instead we're multiplying by the same amount each time. We're doubling or multiplying by 2. My rule here would be multiply the previous term by 2. And there are different ways that you can write this. You could say double the last term, but it needs to be something mathematically that tells you how to get from one term to the next. When we're doing this, we can also find the next 2 values in each sequence. We're going to write the recursive rule in words and then figure out which 2 values would come next. For example, 29, 25, 21, 17, what I see is that the sequence is going down by 4 each time, or I would need to subtract 4 from the previous term. And once I come up with that rule, I can see what the next 2 terms in the sequence would be. So I'm going down by 4, 29 to 25, then subtract 4 to get 21, subtract 4 to get 17. 17 minus 4 is 13. And 13 minus 4 is 9. So I have the next 2 values in my sequence along with my recursive rule. We can also do this with a pattern of letters. And sometimes with the letter patterns, it's easier if you think about how the whole alphabet would be written out to start. So A, B, C, J, K, L, and so on. It keeps going. So if I look at the alphabet, this one starts with A, then goes to C, then goes to E, then to G. I can see that what's happening is I'm skipping one letter each time. So after G, I would skip the H and go to I. And after I would skip the J and go to K. So those are my next 2 letters, I and K. And for my rule, I could say skip one, make this a little bigger, letter in alphabetical order, or in the alphabet. And I would want to give a rule that tells me if I started at K, how would I get to the next one? I would skip one letter in alphabetical order and go to the next one, which would be M, and so on. We can also do this for picture patterns. Here I have 1 square, 2 squares, and 3 squares. So my next picture would be 4 squares all lined up next to each other. And when I write my rule, I would want to explain how I'm adding these squares. So when I wrote my rule, for example, I could say add 1 square to the row of squares. I'm going to try and draw this. We'll see how it goes. Here, I would need a rectangle with 4 squares lined up. And then my next one would have 5. And so on. All of these examples are different types of sequences where you can write your recursive rule showing how to go from one term to the next and also find the next 2 terms in your sequence.